In example 2, we have a trinomial set equal to 0, but we'll be able to apply the zero product property here again once we first factor that trinomial and rewrite it as the product of two binomials. Meaning the first thing we're going to do is rewrite this expression as x plus a times x plus b. In order to find those two values, a and b, we need to come up with two numbers whose product is 36 and whose sum is negative 13. In this case, we would want a to be negative 9 and b to be negative 4. That product would give us a positive 36, and their sum would be negative 13. So we can rewrite this equation as x minus 9 times x minus 4 is equal to 0. Once we have this factored form, now we can apply the zero product property. We'll first solve x minus 9 is equal to 0, and then we'll solve x minus 4 is equal to 0. The first equation gives us x equals positive 9 as a solution. The second one gives us x equals 4, meaning we have two solutions to this equation, x equals 9 or x equals 4. We can do the same thing in example 3, but we're going to have one or two additional steps in this case. What we have is not a trinomial set equal to 0, but we do have an equation that we can rewrite to turn it into a trinomial set equal to 0. In example 3, part A, we'll start off by adding 63 to both sides. And that will allow us to rewrite this equation as x squared plus 16x plus 63 is equal to 0. We'll be able to factor this as x plus 9 times x plus 7, still set equal to 0, and that will give us our two equations to solve. X plus 9 is equal to 0, and x plus 7 is equal to 0. And we'll yield two results, two solutions, x equals negative 9 and x equals negative 7. So we have two different values for x that will make that original equation true. In part B, we need to move two terms to the left-hand side. We'll add 3x to both sides, and we'll subtract 18 from both sides. To rewrite this equation as x squared plus 3x minus 18 is equal to 0, which we'll then be able to factor as x plus 6 times x minus 3. And our two equations to solve will be x plus 6 equals 0 and x minus 3 is equal to 0. This will yield two solutions, x equals negative 6 and x equals positive 3. In part C, we again need to take one step to rewrite this problem before we can factor and solve. We'll subtract 7x from both sides so that we can rewrite this equation as x squared minus 7x minus 30 is equal to 0. We'll then factor that as x minus 10 times x plus 3, still set equal to 0, and set up our two equations to solve. X minus 10 is equal to 0, and x plus 3 is equal to 0, which will yield x equals positive 10 and x equals negative 3 as solutions to our equation. These solutions can always be verified by taking those values one at a time and substituting them back into the original expression. And what you would see is you would end up with the statement 0 equals 0. If not, then either maybe an arithmetic step was wrong, but it's possible that you came up with one or two of the wrong solutions. But we can always take that step to check our work and verify that our solutions are correct or incorrect.